Okay, all right, we're moving on to a new chapter. So technically, quadratic is not done yet. It's not done, but I'm just moving on first. Okay, we'll go. It's never done. It's never really done. So not for you guys until you get to the end of year 12 at least. But anyway, so polynomials is a topic that's quite important. It is very. If you don't understand this, you will struggle quite a bit in the next few chapters, and the next 2 years basically. But the concept is actually not hard. All right.
Just got to substitute the little numbers in the brackets for that x.
Yes, that is correct. You are correct. Yes. Okay. Let's see. Monic constant term. Okay. I will borrow this explanation here and the example. You note.
I'm doing, for next term, I'm doing indices, exponentials, and logarithms, further trigonometry, circle geometry, and consumer arithmetic.
Can you send me that?
Yeah, right.
Yeah, email that to me.
That's like what we did this term.
Yeah. So it's just that you guys got everything crammed into one term, but you got it spread out over like 1 year instead of 6 months. Okay. Anyway, so I'll wait for Daniel to quickly send me that, and then we get started. All good?
Yeah.
Oh, perfect. Okay. All right. Have a look. So a polynomial is written in a form. So look at this form here. It looks a little bit scary. Right? It may look a bit scary. If you're not scared, that's great. But if it looks a bit scary, don't worry about it. It's actually not too scary. Now just focus that this is considered one term, right? Because remember, terms are separated by pluses or minuses, right? So these are all separate terms. And so for example, that's one term, this is the next term, that's another term, and that's another term. So in that expression, there are 4 terms. The ... are saying there are infinitely many terms in the middle. Okay? Now have a look at a structure of each of these terms. So within the first term here, do you see that there are just essentially 2 factors? Right? Don't be scared about the subscript. An just means it's, the subscript n is just saying that it's a number, right? If there are n numbers in here, n means like any number, could be 10, could be 100, could be 1 billion. For any numbers of terms, right, the term will come with the coefficient, right, and then times by a factor of x raised to a certain power. Okay, now the power you normally write in the highest power first, and then the power will drop. You see n minus 1, and this will continue dropping, and then this is power 1, and this is technically x power 0, because what's power 0?
1.
Anything, yeah, is 1, correct? Right, now just b equals to 1, so a0, which is like the coefficient, times 1 is just a0. And this has a special term. This is it's called a constant term. Okay, this is a constant term. I think you guys might have heard of many of these terms before, so I'm just giving you guys a another explanation for all of this. Okay, now the new thing is probably this thing here. So the terms are it's not something new, right? For example, a polynomial, right, could look something like 2x squared plus 3x plus 1. Look familiar? What kind of polynomial is this?
It's what's it called again?
Monic. Say those. Non-monic.
Non-monic? What? Non-monic? Quadratics, yes. It's a quadratics because the highest power is 2. It has a special term, right? And non-monic because the coefficient of the x squared term is 2, it's not 1. Monic means 1. Mono is 1. Yeah, like stereo audio is 2 sides, mono audio is like 1 channel. Okay, so see, monic polynomial is a polynomial where the leading term, now what's the leading term? The leading term is the term with the highest power, right? Of the highest index here. So in this case, the leading term would be 2x squared, right? Because the 2x squared, the leading term is a square term, that's why it's called a quadratics. Okay? And okay, let's see. The degree of a polynomial is the highest degree in the entire polynomial. That's it, right? So what's the degree of a cubic equation? What do you think? The degree of a cubic equation?
3.
3, yes, because the highest power is 3. Right? So remember a cubic equation, a cubic expression can look something like px equals to, let's say, x cubed plus 2x squared plus x plus 1, for example. The highest power is 3, right? So that's why the degree of a cubic is 3. Is this a monic polynomial? This one. Is this a monic polynomial?
Yeah.
Yeah, good, right? Because the coefficient of the leading term is 1. Okay, good. Yeah, that's it. And now the notation p of x, right? It's just saying that the polynomial is the name, we're calling that p. And then the independent variable, or like the variable that will substitute values in, will be x. Alright, so it's a polynomial of a bunch of terms of x. Does that make sense? So that's what p of x means, or p brackets x, yeah, or px. So px is the polynomial of a bunch of x terms. That's it. Okay. Remember, have you guys seen this notation before? Fx. Have you? Amani? No. Daniel? No. This is called a function. So this is the letter p is just a way of calling. You can call it mx or whatever you want, right? Normally they call it p for convention because p is polynomial, p, right? But you can technically call it anyway, right? So fx, so officially fx is a function of x. That's it. So a polynomial function is a function that can be written in this specific form. Okay, so it's a type of function. Have you guys heard of the word function before? F stands for function. What is a function? Okay, I see. So a function is an expression that uses a variable. In this case, x. F of x means the function is called f, and it uses the variable x. Okay, that's a main independent variable where you put some value into that function, it spits out another value. Okay, most of the time that's what a function does. And Daniel, a function in programming does the same thing. Normally, you put in some inputs and then it will spit out some output, or it may not spit out some output. It's a little bit different. Yeah. So in this case, for example, have a look at this example here. So this is a polynomial or a function called p, or a polynomial p of x, and this is the definition of that polynomial. So when you're calculating p1 means you're substituting, you're putting 1 into the main variable. So what's the main variable here? Is x, right? Because px.
1x power 4.
Not 1x power 4, you put it into x. So remember, x is just 1 power 4.
Oh, that's what I meant, yeah.
Yeah, so there's no x in it. It should be 1 power 4 minus 3 times 1 cube minus 2. Yeah, make sense? It's just putting 1 into the main variable, which is x. So that's why the x here is important, right? It tells you what is the main variable, because sometimes the polynomial may not have just x. You see in an example later. Yeah, you see in the next example. But in this one, let's say p1 equals to that, and you just got to work it out. That'll be 1 minus 3 minus 2, which is 1 minus 5, that's negative 4. Right? And then let's say question B here, p of negative 1. Okay, let's put that in. So that would be x, instead of x, I'll put negative 1 power 4 minus 3 times negative 1 power 3, and then minus 2. Is that right? Yeah, is that right?
Wait, no.
No,
yeah.
Why? Yeah? There's something not quite right with what I've written over here.
No brackets for negative 1.
Yes, that's right. You need the brackets. If the numbers that you're substituting in is not just a simple expression like 3 or 2 or 10. If it's negative something, or if it's like a plus b, right? And you see that later. You will need the brackets, especially for negative. Just remember, if it's negative number, you always put the brackets around it. Because why? What happens? If I don't put the negative here, what would this one become? Just this term here, negative 1, everything power.
That would become positive 1.
No, without the brackets, it's negative 1.
Oh.
Because remember, without the brackets, the power only applies to the number, not to the sign in front of it. Okay? And that's why you need to put the brackets in here. because it's negative 1 and then times by itself 4 times, which turns into positive 1. It should be positive 1 instead. Does that make sense, Amani?
No.
No? So,
Like, I understand the concept of having to put the brackets by the negatives. I get that. I
yeah,
just don't get how it'd be.
positive.
Yeah.
Okay, all right. So if you have a negative number, let's say negative 1, everything power 2. This is negative 1 times negative 1. When you times two negative numbers, what would the result be? Positive or negative? Positive, that's right. Right? The answer will be positive 1. Yeah? And if you, so note that this power is even. Yeah? So if you have negative 1 to the power 4, it means you have 2 pairs, right, of negative 1s, like so.
Oh.
Right? So this one would be positive 1, this one will be positive 1, and so it will cancel out the negative. So if the power is an even number, there will be an even number of, there will be like there will be pairs of negative numbers, which will, when multiply, you will get positive and then times by positive, which is positive 1. Okay, so that's just a quick recap on on negative numbers and powers. Okay, how about this expression though? What would that become? Daniel?
-3. Oh wait, which one are you cycling?
Sorry, this one here.
Oh, wouldn't that just be -3?
-3 ultimately. Okay, let's say
because if you times the brackets first, that's just +1, and then if you times +1 by -3, that's just -3.
Okay, so that's what you've got. Now that answer is not correct, and I'll show you why. So the first answer will be so it will be 1, right? Now this one is -3. Note what's the power here? This is power 3.
Oh, I didn't see it very well. I thought it was power 2.
Oh yeah, now you should know why it was incorrect. When it's an odd number of powers, right? Power 3 means it will be -1 times -1 times -1. Now these two will become positive, which is cancelled out, right? Then there's still one -1 left, which means if it's an odd power, right, you will still get a negative number. So that's why that will be -3 times -1, which is +3. So be very careful when you're substituting negative numbers into polynomials. And you -2, that would be 4 minus 2, which is 2. Okay? Yeah? Next is, the next two examples are not too hard. It's just essentially using a bigger number, slightly bigger. So P of 2 would be, once again, 2 power 4 minus 3 times. So you can write it as times or write it as brackets. 2 cubed. I prefer to write brackets minus 2. So 2 power 4, when you see things like power 4, power 5, power 6, right? How I normally do it is this. Instead of writing 2 power 4, I split that into 2 squared times 2 squared. Does it make sense? Daniel, why? How can I do that?
Is it because the I forgot what rule it is, but when you
before then?
When it combines, it will be 4. It will both be 4, correct? But Daniel, what was your explanation again?
It was because like the rule where if you plus powers, they when you plus powers they add, but when you times powers they.
Oh, okay. I think you get the idea, but now
there was this rule. I can't remember it.
Yeah, the idea is this: if you have let's say a to the power b, right, or let's say x power a times by x power b, right? You add up the power, right? When you multiply two powers with the same base, you can add the power together. Remember that, Amani? Yeah, it's indices and logarithms. Yes, it's the index law. It's the very first index law that you guys got. Alright? So for example, if you have 2 power 3 times 2 power 2 is 2 power 5. Right? It's just adding up the power. I'm doing the reverse of that. So instead of having 2 power 4, I split that into 2 power 2 times 2 power 2. Now why do I do this? Because I can now solve this as 2 squared is 4 times 4, that's easy, 16. Does it make sense? So sometimes working out these powers, right? If you split up the power, it will be easier to work with. For example, let's say if I have something like 3 power 4. If you were to work this out normally, it would be supposed to be 3 by 3 by 3 by 3, right? And that would be 9 times 3 times 3, which is 27 times 3. Oh, I'm stuck. 27 times 3 is not something I can do like straight away. Not that easily. Okay, let's not do it that way.
Maybe.
You probably can, but I'm just saying that there's an easier way. So if you split 3 power 4 into 3 squared and 3 squared, what's 3 squared?
9.
By 9
So
is?
it's 81.
81. See, much easier than 27 times 3. I'm sure you guys can do 27 times 3, even by
Just
in your head or
brute
work it
force,
out.
just
You can-
27, like you do like 60 plus 21.
Yeah, 60 plus 21, correct. That is a brute force way of doing it. But all I'm saying is that if it's power 4, you can split that into power 2, power 2. Right, power 2 times the power 2. And sometimes the answer is a lot easier.
Well,
Okay?
then again, you could do the same thing. Like when you had 9 times 3 times 3, you could just do 3 times
Correct.
3.
Correct. You can do 2 times 3 first. Correct. It's the same idea. Yeah. So that's why I'm saying that instead of doing just left to right, if you do that little split there, some of the questions will be a little bit easier. So in this case, 2 power 4 is 2 squared times 2 squared, which is 4 by 4, which is 16. And 2 cubed, well, when a cubic of something is something that you basically should remember. 2 cubed is 8. So that's 3 by 8 minus 2. If you take more lines to do this, that's fine. Just make sure you get the answer right. Okay? And that's actually more important to get the answer right. So minus 26 is negative 10 than trying to do it quickly. Okay? I'd rather you write more, I'd rather write more lines and get it right than like writing less line and getting it wrong. So now question D, last one, P of negative 12 equals 2. Sorry, negative 2 equals 2. Negative 2 power 4 minus 3 times negative 2 power 2. And, power 3 here and then minus 2. Okay, is that right? Is that right, Manny? That's definitely not right.
Can you
But why?
select the original again?
Yes, I can. Or actually, Daniel, I think you know.
Actually, hold on, let me read this first. You'd need a bracket around the negative 2 in the front.
Yes, that is correct. The brackets around the negative 2 in the front. Okay, anything else? Anything else that's wrong with this?
I want to say it, but I don't think it's right. I don't think it's right though.
You don't think it's right, but why?
Oh, wait, can I see?
What the-
Wait, which question are you doing here?
Is this one here? Is there anything wrong with this?
Oh, the bracket is... the bracket takes out the
Oh.
negative 2 and the power of 3. It takes up the entirety. It's supposed to only take up negative 2.
Yes, that's right. This little bracket here should be here only. Yeah, that should be only for the negative 2, and then you raise to power 3 of the whole negative 2. Yeah, not outside of it. Alright, okay, so yes, what's negative 2 power 4, Manny?
You can do the negative 2 tree.
Which is? What's the final answer?
16.
16.
Positive or negative?
Positive.
Positive.
You're not helping. I know you know the answer, so I'm not asking you. I'm not asking you because I know you know the answer. Okay, it's not because I questioned your
just saying,
intelligence.
like, who is it?
You need to let. Yeah. I'll make it clear if it wasn't clear, but that's why. Amani, do you know why it is 16? Remember, these little things about negatives is what you are missing out on the most.
Yeah.
Okay, why? Explain.
Well, because 2 power 2 is 4, and then times the 4 by the 4 is 16.
Okay.
Then the positive and negative is positive. Negative, sorry.
Okay. So this would be 16, right? And then minus 3. Now, Amani, not Daniel. Amani, what's the answer to this one? What's negative 2 power 3? Times by what? What goes in these brackets here? You have to know.
Yeah.
You have to figure it out.
I don't know how to.
Faster.
So negative. Remember what did I say about an odd power? If a power is an odd number, what happens?
It's positive
Why is it positive?
because there's a negative and it's positive.
If it's a negative, why is it a positive? What's negative 1 power 3?
Positive 3.
Positive 3?
What?
That's very off.
Negative 3.
How did you get 3? What's power 3? Power 3 means is negative 1 times negative 1 times negative 1. Please go back and do the can work. Okay? I'm assigning you the can work so that you will make these calculations quickly. Alright. This is the standard. Like these questions are considered simple familiar. So next term they will teach you these things and I expect that you should know something like that straight away. And negative 1 times negative 1, one of the pairs will become positive, right? But you still get another negative 1 here. And that's why the final answer will be negative 1.
I'm so lucky we're doing this in the holidays.
I was focusing on the top bit.
The top bit, like the power 3?
Yeah, I was focusing.
Yes, the power 3 just means it's multiplied by itself 3 times.
Yeah.
Yeah? So what's the answer here then? Negative 2 everything power 3.
16.
16 is power 4. Power 3 is not 16. Give her like 10
Is it
seconds,
negative or
Daniel.
positive?
Do you think it's negative or positive? If the power is...
Negative?
It is negative because the power is odd.
Negative 8.
Yes, negative 8, thank you. Good. Alright, we got past that. Okay, and then minus 2. Alright, Daniel, complete the rest.
Alright, so I'll start with the 16.
Mm-hmm.
Then I'll go negative 3 times negative 8, which is positive 24.
Mm-hmm.
Then minus 2.
Mm-hmm.
So then I add those two together. So that's 40 minus 2. So that's 38.
Yep, the answer is 38, correct. Okay, so yes, so that's that. Now, substituting numbers in and calculating out stuff is something that you guys will definitely need to practice on later. I'll just go through all of the examples first, okay? For the sake of the recording, I'll go through all of them first, and then when we get to the... Oh, wait, skip past that. Okay, when we get to the questions, you guys will... I'll go around and help you guys on if you guys have any questions for these. But I will go through the main content first. Alright, next, example 2. Now, what do you see is the difference between this example and the last one? Let's look at question A. How would you describe the difference between this question and the last one? Daniel, what's the difference?
Wait, when you say the last one, you mean like the one...
The one before that we were trying to do, like these ones here.
Is it because they're saying if P1 equals 21?
Yes, they give you the value when you substitute 1 in. Okay, they're not asking what the value is. They give you what the value is. They ask for something else. They ask for...
X. Oh, C.
Yes.
Oh.
They're not asking for X, they're asking for C, an unknown constant in here. C stands for constant most of the time. Okay? Now sometimes they'll use A and B for constant as well. Alright? So in this question, what they're asking you to find is not the value of X, is not the value of the polynomial when X is a certain value. Unlike the previous question, they're asking you to find the constant inside the whole polynomial. So let's have a look. We need to use what they give us, P1 equals to 21. Okay, so when you have P1 equals 21, it means that when you sub...
Does that mean P is equal to 21?
Yeah, correct. So P equals, X equals 1 and P would be equals to 21. Okay, so then you get 21 equals to this whole thing, but instead of X, you get 1 as X. So that would be 2 times 1 power 4 minus 1 power 3 and plus, well, if it's just a number, you can get away with writing just a number. So 2 times, okay, I'll write this way, 4 and then plus 2c times 1 plus 6 Okay, how do we solve for C?
Oh, I get to answer.
Yes, Daniel, you get to answer this one.
So it's 2. 21 is equal to
21 equals 2. Well, before you continue, explain your idea first. What are you doing here?
I just times each of the I just do the order of operations for each of the factors.
Correct.
And I put them all together.
Yes, so what Daniel's saying is that you simplify, right? The main term is simplify each of these terms here, right? Anything that looks complicated, you simplify them first and then you combine them after. So yeah, Daniel, continue.
Alright. 2
correct.
minus 1
Yep.
plus 2c
2C
plus 6.
plus 6. Okay. Amani, what would be the next idea here? Don't do it yet, just tell me what's the next idea.
Would you move one of the terms over to the 21 side?
Yes, you are correct. Now, in fact, you move every single non-C term over. Remember, the term comes with the sign in front of it, yeah? So you move every single one of these terms, move them over to the left-hand side. Okay? Alright, Amani, you do that then. It'll be 21 and
Alright, got it.
pause.
Plus 2
Nope.
is it negative 2?
When you move a term across to the other side, you change the sign. Yes, it's negative 2.
Plus 1
Plus 1
minus 6
minus 6
equals 2c.
equals 2C, correct? Alright, simplify this one. Daniel, what's C?
It's 7.
Yeah, that's right. So when you simplify this, I would do this. 21 plus 1, which is 22. Right? And then subtract 2 is 20. And then you subtract 6 is 14. But you can do that step by step on the side as well. Okay, if you need to. But that's what I'm saying, Amani, you need to practice on the camera. There will be many questions where you get to practice this quick mental calculation. Remember, you got to rely more on your brain, not less on the calculator. Train your brain for math. 14 equals to 2C, which means 7 equals C. Divide both sides by 2. Okay, that's it. Now, that's question A. Have a look at question B. What's the difference between question A and question B? Anyone?
There's a
Daniel.
Q in there.
Yes, it's Q. It's called a different polynomial. Sorry?
They give you 2.
They give you 2. Yes, they give you 2 of them. Okay. And there's one more thing that you guys can talk
Find the
about.
values A and B.
Yes, they ask you to find 2 things. So if they ask you to find 2 values in a polynomial, what idea do you guys think is the biggest, like the overarching idea here? How do you find 2 values?
You have to split it.
You have to not quite split it.
You just solve it the same way.
You would solve it in a similar way, but not the same. And there's an idea that's overarching when you're trying to solve
Oh,
for
is
2.
it like
You'd
Start with
solve
S.
one and then you'd solve what's that?
You can't solve one.
Because-
You can't solve one first. You have to solve them. Start with an S together. What's the term for it?
Simplify it. Solution.
No.
Oh no.
You have to solve the
simultaneous equations?
simultaneous equations. Yes, simultaneously. Alright, simultaneous equations.
Solution.
Okay, so you do need to solve them simultaneously for question B. So let's see. In order to solve two values in the same equation, how many equations do we need? How many equations do we need in order to solve for 2 values?
2.
2. That's right. If you're solving for one value like C, you need 1 equation. See, that was only 1 equation,
Wait,
right?
Like Q equals -1 equals to Q equals negative. Are they meant to be like correspond to A and B, or are they just?
No, Q -1 just mean when you sub -1. Okay, so you technically need to split. So say this one, the Q -1 equals Q2 equals 0. You technically have to split that into 2 main logic. So the first one is that Q -1 is 0, and the other one is Q2 is also 0. Okay? So if Q -1 is 0, means that when you sub x equals to -1, the Q value is 0. So you start with substituting 0 into Q, and then equals to, so basically it's this equation here, right? But when you sub x equals to -1, you get q equals to 0. And that's what we're doing now. So that'll be 2 times -1 power 6 minus -1 power 3 plus a times -1 squared plus b times -1 plus 20. Okay, this question is everything in here is considered simple familiar for math method. So Amani, if you find these ones difficult, you better do my canned homework. I will need to give you more. You have 3 weeks to get yourself ready for this. Okay, you better do math every day. I'm not joking. Okay, if you want to get better, if math is the only thing that you're weak at right now, the canned homework, I promise if you do that, you will feel everything a bit easier. You have to work hard the next 3 weeks. Okay? You have to work hard the next 3 weeks because you're behind in terms of these basic algebra skills. And this is the perfect time, 3 weeks, you can get up to speed, but you gotta just do can every
I
day.
think any of these questions are even hard. I think they're just long.
You're correct. They're not hard, they're just long. That's why they're considered simple familiar. Simple.
You know
Yeah?
him, but you just don't like him.
Hey?
You know him, but you just don't like him.
Yeah. You know them, but you don't like them. You're right. But anyway, yeah, so you work these ones out. So you simplify that. You would get something like, note that this one is only for q -1 equals to 0. Yeah, so that 0 equals 2, -1 power 6 is just 1. So that's 2 times 1 is 1 minus -1 power 3 is actually, maybe I'll simplify that. That'll be 1, and then this one will be -1 plus a times -1 squared will be +1 plus -1 times b is actually becomes -b plus 20. I think, yep, plus 20. Keep simplifying. 0 equals to 2 plus 1 plus a minus b plus 20. So combine all of the constant term. I'll get 22 plus 1, 23. So I'll write it as a minus b plus 23. This is my first equation, number 1. Because remember, when you're solving for 2 variables a and b, right, you need equation 1 or one of them and equation 2, and then you work them out together.
Could you use just simple logic to say that a minus b is equal to -23?
You can, yes, you can. The reason, yeah, you can technically write that way. Okay, maybe I'll do it. I'll do a standard way where I put 23 over to this side, and then I just leave a minus b over here. So then this one is equation 1 instead. All right. Now the next step is I need to use. Okay, so the idea here is if I were to use q2 equals to 0. It means that sub x equals 2 and q equals to 0. Alright, so now we get 0 equals to 2 times 2 power 6 minus 2 power 3 plus a times 2 squared plus b times 2 plus 20. I'm just copying off the formula over here. I think that's right, 2x power 6 minus x cubed plus 2 plus 8. Yeah, that's right. So yeah, I'll save you guys the trouble for now and work, just finish this one off first, okay? And later you guys have a chance to work through these questions. But Amani, you probably need to do the can work first, otherwise you will really struggle doing these ones. So do the can work first, and then you can try some of these later, maybe in the second half. Okay? Daniel, your goal is to finish every single question. Okay, every single one of them. See if you can.
That's fun.
Yeah. Anyway, so 2 to the power 6 is what? Let's work it out here. 2 power 6, again, the trick I mentioned earlier, split it like that. Alright, it's 2 squared times 2 squared times 2 squared, so that's 4 by 4 by 4, which is 16 by 4, and if you have done enough of that, you know that it is 64. Then you need to times that by, so that will be 2 times 64. I will do a bit at a time. 2 cubed is 128, yes. But yeah, so I'll go 4a plus 2b plus 20. So that will be 128. Did you say 48? 128.
No, I said 128. Yeah.
Did you? Oh, then yeah, 128. Plus 20 equals to 0. So 0 equals to that minus that will be 120. Plus 20 will be 140. Plus 4a plus 2b, and then I want to move the 140 over to this side. 140 equals to 4a plus 2b. Can I simplify this?
Yeah, you could say 70 is equal to 2a plus b.
Correct, because I can divide both sides by 2. And remember, when you divide both sides by 2, you have to divide every single coefficient by 2. So that would be 70 equals to 2a plus b. All right, now that's equation 2. So just to help you guys out, I'll rewrite the equations 1 and 2 here and see how we can work it out. So equation 1 would be negative 23 equals a minus b. Equation 2 is 70. Oh, sorry, it should be negative 70. When you move the 40 or 140 over, it becomes negative. So negative 70 equals to 2a plus b. How do we solve these two equations simultaneously? How do we get rid of one variable so that you can solve for the other?
I'm guessing you would have to turn into a quadratic.
No.
Oh, okay.
Luckily, there's no quadratic in this one.
Oh, thank God. All right.
You do something else though. You have to combine these two equations somehow. You have to combine them in a way that will eliminate one of the variables. So if you guys 2 hints. Option 1, right? Option A, you do equation 1 plus equation 2. Option B, you do equation 1 minus equation 2. Option C, you do equation 2 minus equation 1. And option D, you do equation 2, right? Equation 2 minus 2 times equation 1. Which option? Multiple choice, A, B, C, D.
I'm just gonna say it's not A or B.
Not A or B?
Yeah.
Okay, so you're picking C or D?
Yeah.
D.
Okay, Amanda is picking D. Daniel, what are you gonna pick?
I'll take D.
You take D as well?
Yeah.
You're both wrong. You think the complicated one is the right answer? No, that's not the right answer.
Oh.
The right answer is option A.
Oh.
What happens when you add them together? Look, if you add them together, you're just adding term by term, right? What's negative b plus b?
0.
0, it's gone. Okay, what's a plus 2a?
3a.
3a, right? What's negative 23 plus negative 70?
93.
Negative 93.
Negative 93, yeah.
Suddenly, you got negative 93 equals 3a. Can you solve for a?
Yeah.
Yeah.
So that's negative 31 is equal to a.
Negative 31 equals to a. See, you've got 8 already. It's easier than you thought, right? It's actually not too bad for these questions. Okay, and then how do we solve for b?
Would you
Minus it?
Almost. You have to sub this into one of the equations.
Oh.
You sub into, I would choose the first one, right? Because it will be just a here. I don't have to.
31 minus b. I'm guessing that b is a negative. Well, not guessing. I would presume that b is a negative because it would be like brackets negative something. So it would be negative 31 plus something to make it 23. So I'm guessing b is negative 8. Like
Yes,
brackets negative
you're correct.
8.
Yeah, you're correct. But I'll just work it out the algebra way, okay? Make things a bit easier. So first, I will take the negative b term and move it over here, all right? So that'll be negative 23 plus b equals negative 31. And then, because I just move it over there so that the b is a positive term, yeah? And then I move this term over here, which means the left-hand side only has b, and that right-hand side is 31 plus 23. So if you work this one out, it will be negative 8. So yes, b is negative 8 and a is negative 31. These are the two answers to this question. Okay? So yes, so this is one of the harder type of questions that you will see in Unit 1. Okay, let's see. Alright, I may pause my explanation here. So Daniel, you can you give it a go. Try out these ones. Here's the sheet for 8A. Okay, so try out question A for all of them. I'll pause the recording first. Okay, so for whoever's listening to this recording, make sure what you will try now is question 1A, 2A, 3A, and 4A. Alright, do those ones first. If you can, then you can do the rest of those question 1, 2, 3, and 4. Don't do 5 and 6 yet. Okay, at this point, you cannot yet do question 5, 6 or anything beyond that. Okay, let's continue. So we're moving on to example 3 and 4. Same thing after that, I'll tell you guys what questions to attempt. Okay, it's gonna be a bit challenging. But anyway, so example 3 is about arithmetics of polynomials. So for example, right, A and B. So if you notice, question A and B is just about adding or subtracting the polynomials, but C is about multiplying them. Now C is the one that is a little bit longer. Yeah, C is going to be a little bit longer. All right. So okay, so I'll go through question A first. B actually I'll go through question B. Okay. Px minus Qx. So when I see Px, I just put whatever Px is into. So okay, let's write this one first. Px minus Qx. So instead of writing Px, I will expand that. Right. Px is x cubed minus 6x plus 3. Right. That's Px. Yeah. And then minus, I'll write in different color, Qx is x squared minus 3x plus 1. That right? Yeah? No.
Should it be positive?
Sorry, what positive?
X. Hold on, let me just think this through before I say anything.
Mm-hmm.
Should it be positive x squared?
Positive x squared? Why positive x squared?
Because the qx equals x squared is positive.
Okay, okay. That's a good point. Well, what brackets?
Like on the two factors, like Px and Qx.
No. Both of you are wrong. The idea is I didn't write the brackets here. So Amani, you're not wrong.
Half right.
You're half right, yes. Half right, okay? Brackets were in the wrong place. So Amani, yes, it should be positive x squared because I should have put the brackets around it. You see?
I could put brackets there, right? I could put brackets there, right?
At the Px and Qx, like here?
Yeah.
Yes, but normally not.
Oh, right.
Normally you only put the brackets once you expand it and there's more than one term. Alright, so Qx has 3 terms, yeah? These 3 terms here. So that's why you put the brackets around it. And then you would expand it as usual. So expand the first one will be the same. Now, what happens to everything in here if it's minus? The negative in front of the brackets, what does it change? What changes does it make to these ones?
It becomes negative x squared plus 3x minus 1.
Yes, so it flips the sign of every single term in the brackets. Does it make sense, Amani? So x squared, right, becomes negative x squared. Negative 3x becomes positive 3x, and positive 1 becomes minus 1. All because of the negative in front of the whole brackets. Okay? Yeah, so that's what you need to keep in mind. So then combining like terms. X cubed is the same, we can't simplify that. Minus x squared is also the same, can't simplify that either. And then minus 6x plus 3x is negative 3x, and then 3 minus 1 is 2. Okay, so that's when you add or subtract polynomials. The next one is C. Now this is a tricky one. Px times by Qx. Remember when they write nothing in between, it's an implied multiplication.
Sorry, would it be better to put like an x, like the times symbol in between?
Sorry, yeah, you were saying?
Would it be better to put the times symbol in between?
Would you put brackets on both of them?
Correct. You can put a times in between, but you don't really need to. It's implied. Yeah, it's implied that it's multiplication.
Though, but like if I was to, no.
Yeah, no, you wouldn't see a question with the times in between. I think most of the time you wouldn't see it. Amani, any thoughts? No. How do we expand this? You guys did something similar, somewhat similar in quadratics. It's this thing.
Yeah, I was about to say that, but also drinking water.
Yes, it is that thing. Okay, so I will take x cubed times by each of these.
Oh, I thought you had to like do each of the quadratics. Like, wait, no.
No, we're expanding this one.
Oh.
Okay, expand and combining like terms. So that x power 5 minus 3x power 4 plus x cubed. Okay, make sense, Amani? Yeah. And then it will be this term times into each of the terms in this brackets here. So that'll be negative, I'll write in a different color, easier to see, negative 6x cubed, and then positive 18x squared minus 6x. And finally, you gotta take 3 times by each of these terms here. So then that will be plus 3x squared minus 9x plus 3. And now we combine like terms, right? Power 5, any other power 5? No. So write that one first. Power 4, any other power 4? No. So negative 3x power 4. Power 3, any other power 3? Yes, these two. Alright, so that will be plus 1 minus 6 is negative 5 x cubed. Squared, anything squared? Yes, these two. So that will be plus 21 x squared. And then x would get these two as well, minus 15x. And then constant term, there is only 1.
Is that a 9?
Sorry, which one?
The one that...
Is it 4?
9x.
Okay.
Yeah, because it's 3 times negative 3, so it's negative 9x, sorry. Yeah. Poor handwriting. Yeah, that's it. Final expansion. You can't combine them further, just all the like terms combined. What is the degree of this polynomial? Degree is
5?
correct. Degree is the highest power. Okay, what is, so is this a monic or non-monic polynomial?
Non-monic.
Monic.
Monic or non-monic?
Monic.
Why monic?
Because it's
Is monic
the
one?
biggest...
Yes, monic means 1.
Because
Okay.
the most... Like, I forgot what it's called, the most...
One of the highest powers.
The highest power, not one of, the highest power has coefficient 1, right? This is called the leading term.
Oh.
Okay, the leading term has, right, coefficient 1, and that's why it's a monic polynomial, okay, of degree 5. So that's the language of polynomial. Okay, last example. I think this one might be potentially tricky. We'll see. Oof, okay, all right. Okay, now this question is a little bit different. So I'll highlight the key information here. So this polynomial, and then it can be written in this form here. Alright, where B, C, R are real numbers. So they're just some numbers, and you gotta find what B, C, and R are. So look at this one. The idea is that if two polynomials are equal, right? Because can be written in the form literally just means equal. Yeah. So Px is also equal to this thing. If it's equal, then every single term must have the same coefficient. So for example, so I'll give you an example of the concept first. Let's just say that x cubed plus, or say x squared plus 2x plus 1, right, is equals to ax squared plus bx plus c. What's a, b, and c?
Oh, A is equal to 1.
Yeah, b
B
is
is equal to 2.
yeah, and c is
equal to 1.
yeah, correct, right? If two polynomials are the same, then the coefficient of each of the term with the same power must also be the same. But look at this one here. At the moment, this one is not in the same format as this one, right? It's not in the same form, right? In this one here, Px, there's no brackets, right? This one has no brackets, but this one has brackets, right? This one has brackets. So you want to convert them both into the same form so you can compare the coefficients. So do you want to convert this one into brackets or expanding the brackets of this one? Which one do you want to do? Number 1 or number 2?
Number 2.
Yes, expanding brackets is always easier than trying to make brackets. Okay, so that's why we will try to expand. Right, we're trying to expand x minus 2 and x squared plus bx plus c plus r. Okay, we're trying to expand this one. And once again, it's that thing where you have to do the rainbow thing again for the x. So that would be x cubed plus bx squared plus cx. Okay, and then you go minus 2 times into each of these. So minus 2x squared minus 2bx minus 2c plus r. Okay, what's next? Can we see the like terms from these two expressions yet? So remember, px is so px. Right, so this one should be equals to px as well because it can be written in the form means equal. So I'll write x cubed. I'll write what px is, which is this one here. 2x plus 1. Can you combine the terms yet? Can you see what the coefficients are yet? Not quite, right? It's not quite easy to see. So we need to combine like terms. This one is a like term to this one. Right? Because they're both squared. Right? So I will combine the like terms. So that would be x cubed and then plus b minus 2. You just take the, you essentially just combining the 2. So that will just be plus of b minus 2 times x squared. Does it make sense? Think for a second there. Daniel, any question?
The x, because it's a common.
Yes. Common.
Not term.
Not term. The other one.
Little,
start with f.
Factor.
Yes, common factor. That's right.
Because it's a common factor, you
Correct.
then take it outside the brackets, and the
Very
other
good.
two are like.
What's left
not
behind?
Common factors, so you put those in the background.
That is correct. Yep.
It's timesing by both because the x is a common.
Yes, that is correct. So what our manager said is literally the explanation for why these two will combine into this one here. Okay, so visually it looks something like this. So bx squared or plus, right? And then minus 2x squared, right? You take the common factor out, right? If you take that out outside, right, inside will be this, and it will be positive, right? Because we're taking positive x squared. And positive b minus 2 is just, you ignore the positive, right? Just be b minus 2 times x squared, which is whatever that one is here. Okay, so that's the visual explanation of that one. Then combine like the next two like terms, I'll highlight to make it easier, is these two here. Then you're combining them, what would that be?
What does it be, like, negative 2b, no.
Would you do the bracket thing again?
You do the bracket thing again.
Let's say that. Brackets negative 2b plus c.
Yes, but I would keep them in the same order to not confuse myself, right? It will be c minus 2b, right? Because c goes first here and 2b goes after, and then it will be a plus at the front. Remember, it's a term. And what's outside?
X.
It's just x, yeah. All right? And then these two, there's no x in it, so you just simply combine like terms by doing plus and take out 1, right? So in the brackets, it will be minus 2c plus r, like so. Okay? Now, what is the coefficient of x squared on the left-hand side? So I'll rewrite it here, yeah? So x cubed plus 3x squared plus 2x plus 1 must be equals to the other expression. So what do we know? This is the x squared term on the left hand side. What's the x squared term on the right hand side? This one. So what can we say then?
B is equal to 5.
Yes, but you're skipping too many steps. First, you equate the two coefficients, right? So b minus 2x squared equals 3x squared. So b minus 2 must be equals 3. Move the 2 over. 5 equals b. Okay? Now, what can you tell me about the next two terms here?
Uh, 2x is equal to bracket c minus 2b.
2x is equals to bracket c minus 2b is incorrect.
X.
Yes, but you normally wouldn't put the x. You're only comparing the coefficients. Does it make sense, Amani?
Yeah.
Yeah? So it's like saying 2 times x is the same as c minus 2b times x. That means these two must be the same. Because they're both times by x on the two sides.
Oh.
Yeah? Because they're both coefficient of x. So they must be the same. And what do we know about b?
It's equal to 5.
Equals to 5. So you can stop that in here. Equals to 5. 2 equals to c minus 10. Bring the 10 over. So 12 equals c. Alright, so that's the second answer. Okay? Now, what is the last equation I can form then? Anyone? Daniel?
Negative 2c plus r. Wait, so I know that c is equal to 12.
Yeah, but you want to find out, you want to make an equation equals something.
It's equal to 1.
Equals to 1, that's right. Or I'll write it, left hand side is 1, okay? And right hand side is negative 2c plus r. You see that, Amani? This is a constant term, and the right hand side constant term is this thing here. Okay.
It's negative 24 plus r is equal to 1.
Yep, 1 sec. Let me just redraw them out in the same color so you can see.
So therefore r is equal to 25.
So 1 equals to negative 2 times 12 plus r, 1 equals to 24 plus r. So yes, 25 equals r, or r equals 25. Same thing. Yes, these are the three answers.
For the other one, you said that, but that would be equal to negative. Because if you take 24 and you move it over, that would be.
Oh yeah. Sorry. Yeah. This would be negative 24. Yeah. Because negative 2 times 12 is negative 24. Yeah, that's right. Okay, does it make sense?
Is that just all we've got to find?
Yeah, you gotta find B, C, and R. See? Find the values of B, C, and R. That's it.
Alright.
So this is one of the harder questions. Okay, quite complicated in order to do. So whoever is listening to the recording, we're gonna try out these questions next. 5C. Oh, sorry, 5. Yeah, 5A, B, C, and okay, let's see, 5A, B, C, and E.
Enough time to do like all.
Probably not, but I'll just list them out anyway. So 5A, B, C, E, and question 7.
Or no 6?
Sorry?
No 6?
No, 6. No, we'll skip 6 for now. 6 is very similar to a quadratic thing that you guys were doing in
The
the
whole
past.
of 7?
Yeah, a whole of 7, yeah. 7 is challenging. Okay, question 7 is a little bit challenging. Okay, alright. So whoever's listening to the recording, that will be the end of the content for today's lesson. If you have any question, make sure you ask me on Discord. I'll pause the recording now.